Okay, friend, let's see the last unit, rubber compounding ingredients. um, Peptization. What is peptization, and explain it with example, the role of peptization. So let us first understand what the process of peptization is. Suppose there is a beaker. In that beaker there is a solvent and a solute. A solute is in the precipitate form, and it is a solution of solvent plus solute. So we want that precipitate to not to stay as a precipitate. We want to stay it as a colloidal solution, means moving here and there, not settling down. So to make that solution colloidal, we have to use peptizing agent. Okay, so let us see in theory. Is the process responsible for the formation of stable dispersion of colloidal particles in dispersion medium? So what is it? It is the process responsible for the formation of stable dispersion of colloidal particles in dispersion medium. In other words, it may be defined as the process of converting a precipitate into colloidal solution by shaking it with the dispersion medium in the presence of small quantity of electrolyte. The electrolyte used in this process is called as peptizing agent. Now you may have understood that how does the stable dispersion of colloidal particle is formed. It is formed because of peptizing agent, and the peptizing agent used is nothing but an electrolyte. And what is an electrolyte? In chemistry, substance that conduct electric current as a result of a dissociation into positively and negatively charged particle called ions, which migrates and ordinarily are discharged at negative and positive terminals, cathode and anode. Positive particles travels towards cathode, negatives towards anode. Okay, so of the electrical circuit. So now this peptizing agent is an electrolyte. Suitable amount of electrolyte are obtained. The precipitate are stirred in the dispersion medium in the presence of electrolyte taken in small proportion, and the precipitate are converted to colloidal particle of solution, and solution is obtained. This transformation method is peptization. So what we do, first we take suitable amount of electrolyte, then the precipitates are stirred in the dispersion medium, okay, in the presence of electrolyte taken in small proportion, and the precipitate are converted into colloidal particle and solution is obtained. So as soon as we get the colloidal solution, the peptization is done. So therefore this transformation method is peptization. Now this is particularly important in colloidal chemistry or for precipitation reaction in aqueous solution, when colloidal particles bear a same sign electrical charge. They mutually repel each other and cannot aggregate together. Freshly precipitated aluminium or iron hydroxide is extremely difficult to filter because the very fine colloidal particle directly pass through the paper filter. So aluminium or iron hydroxide are extremely difficult to filter because they are very fine colloidal particle and directly pass through the filter paper. To facilitate filtration, the colloidal suspension must be flocculated, first flocculated by adding concentrated solution of salts to the system. Multivalent cations are more efficient flocculant than monovalent cations. So flocculation is nothing but forming a jhag kind of thing. So multivalent cations are the ones having +2, +3 charge, and monovalent cations are having only plus charge. So in the synthesis of titanium dioxide nanoparticle, peptization involves adsorption of quaternary ammonium cation on the titanium surface. This causes the surface to become positively charged. Electrostatic repulsion of primary particles in the agglomerate titania breaks up the agglomerate into primary particles. So peptization is also used in making nanoparticles. So what basically happens in peptization, you just add some electrolyte to it, and if they are having the same charge, like positive, they will keep on repelling each other. So they will keep on repelling means there will be constant collision and then going away, collision and then going away. So when there is such a disturbance, no precipitate can stay, okay, as a precipitate. It will also start colliding, and then the whole system will be a colloidal solution. So same thing happens in case of titanium dioxide nanoparticles. So here there is a adsorption of quaternary ammonium cation, which is N plus and 4 R radicals around it on the titanium surface. So it becomes positively charged, then it collides with other positively charged species, and then the whole electrostatic repulsion of the primary particles in agglomerate titania breaks up the agglomerate into fine particles. Because of the collision, there is breaking into fine particles, and that's how titanium nanoparticles, titanium dioxide nanoparticles are formed. So this is all about what is peptization, and explain it with example and the role of peptization. Now, what is chemical peptization and physical peptization? Chemical peptization describes the thermo-oxidative catalyzed breakdown of the rubber at elevated temperature. So thermo-oxidative catalyzed breakdown. Thermo means heat is there, oxidative means loss of electron is there, and catalyze means fast breakdown of rubber at elevated temperature. This is chemical peptization. Peptization of the lower viscosity. Peptization and lower viscosity it produces facilitates incorporation of fillers and other compounding ingredients. So we all know lower viscosity of rubber is needed to add ingredients, fillers, everything. So peptization gives lower viscosity. Therefore, incorporation of fillers and other compounding ingredients and can improve their dispersion into the rubber. Improved compound flow leads to easier production of semi-products such as profile or molding blanks, shorter processing times, and lower power consumption are optimal. So because of the compound flow, easier production of semi-products such as profile or molding blanks, and shorter processing times and low power consumption are optimal. So this is the advantage. It is often difficult to homogeneously blend rubber with different viscosity. In this case, the high viscosity rubber can be broken down through peptization to enable improved blending with other low viscosity elastomer. So there is a low viscosity elastomer and there is a high viscosity elastomer, that is the rubber that is hard. So it is very problematic to blend them together. So in this case, peptization helps to break down the higher viscosity into lower viscosity, and then the blending can be easily done. During recent times, physical peptizers have gained major importance. Now this is physical peptization. They act as internal lubricant and reduce the viscosity without breaking the polymer to be very effective in this role. So they act as internal lubricant. Okay, they reduce the viscosity without breaking the polymer. In the earlier case of chemical peptization, there was breaking of polymer. They act as internal lubricant and reduce the viscosity without breaking the polymer. Generally, zinc soap have proved to be very effective in this role. So zinc soap is the example of physical peptization. One can distinguish between chemical peptization and breakdown or viscosity reduction to lubricants, while mechanical and chemical breakdown of the elastomer results in chain scission, a low molecular weight and broader molecular weight distribution are obtained. Lubricants do not change the molecule chain, that is, they are not broken. So that's how you can distinguish between chemical and physical peptization. The only difference is they act as internally in physical peptization without breaking of the chains, but in chemical peptization there is breakdown of chains. So now explain mechanism of mechanical peptization. During mechanical breakdown, the long chain rubber molecules are broken under the influence of high shear from the mixing equipment. So mechanical peptization will naturally use mechanical equipment like mixing equipment to break down the rubber chains. Chain fragments with terminal free radicals are formed, which recombine along chain molecules if they are not stabilized. So chain fragments with terminal free radical will be formed, and then they will recombine with long chain molecules if they are not stabilized. Though atmospheric oxygen, the radicals are through atmospheric oxygen, the radicals are saturated and stabilized. The radicals are shorter, the molecular weight is reduced, and the viscosity drops because of atmospheric oxygen. So this is the chain fragment with terminal free radical. Okay, this is the longer chain molecule, so they are forming higher molecular weight compounds, long chain molecules. They are recombining with the long chain molecules. So because of these radicals, so these radicals are stabilized by the atmospheric oxygen O2, like this, ROO star, two molecules of this, and then star, ROO star, and RO star plus RH, ROH. So here you can see he has reduced the chain, this atmospheric oxygen. So radicals are shorter, the molecular weight is reduced, and the viscosity drops. To stabilize radicals, they must be able to react with oxygen. The affinity of allyl radicals for oxygen depends on other groups in the chain. Electron repelling groups like methyl enhances the affinity. Strongly electron attracting groups such as CN have affinity for O2. Therefore, RO star radicals can accumulate in the chain, resulting in branching and gel formation. So this is all about mechanical peptization. Because of oxygen, the chain length is reduced. First we were getting ROOH, now we are getting only ROH. Give example of peptizing agent. Common peptizing agents are DBD plus activators and pentachlorothiophenol PCTP plus activators, zinc pentachlorothiophenol. The activator permits breakdown to start at lower temperature and accelerate thermo-oxidative peptization. Okay, these two names you have to remember. Three names, sorry. Give benefits of peptization. Accelerate peptization. Peptization speed is increased by peptizing agent. Reduce power consumption. Naturally, low viscosity means no power consumption. Then promote batch to batch uniformity. Facilitate blending of elastomers, like I said. Reducing mixing cost because of low viscosity. Improve dispersion because incorporation of fillers is easy. So this is the benefit of peptization which you have to remember. So this is all regarding peptization. I hope you understand. Read it again and again, you will get it. Thank you.